The topic of this problem is mesh analysis, and we're working with circuits with dependent sources. The problem is to find the mesh currents in the circuit shown below. We have a circuit that has a 15 amp source, it's an independent source, and it also has a voltage controlled current source, which is controlled by the voltage V sub x, and V sub x is defined as the voltage drop across the 3 ohm resistor, the right hand side of the circuit. So we have a dependent source and we have an independent source and several resistors in the problem. What we're looking for again are the mesh currents. So if we're looking for the mesh currents and we're doing mesh analysis, then we know the first thing we do in the problem is we assign loops or meshes, and we can assign mesh currents associated with them. So for instance, we'll call this mesh 1 and have mesh current I sub 1. We'll call this mesh 2 and we'll have mesh current I sub 2, and we have mesh 3 at the bottom right hand side and mesh current I sub 3. So now we can write our mesh equations for each one of our loops or meshes. So we have 3 meshes and we can have 3 equations that are independent from one another from those 3 meshes. So let's start with our leftmost mesh. If we start in the lower left-hand corner of this mesh and go around this mesh, what we find is that we have a voltage drop across the 15 amp source, another across a 1 ohm resistor, another across the dependent source, and across a 2 ohm resistor. We know that when we're doing mesh analysis, what we're looking for the mesh currents. That's what results from our mesh analysis. So in this first loop, the leftmost loop, we know what I sub 1 is, so we can write it directly. So our first equation is I sub 1 is equal to 15 amps, because it's the only mesh current which is associated with this 15 amp independent source on the leftmost side of our circuit. So let's continue on to mesh 2 and look at mesh 2. If we want to sum up the voltages around mesh 2, again we can start the lower left-hand corner and proceed around the mesh. So if we do that, we first encounter a 1 ohm resistor with a voltage drop. And so the voltage drop for that 1 ohm resistor is 1 for the 1 ohm resistor times I2 minus I1. If we continue around this mesh, we encounter the 2 ohm resistor next. And the voltage drop there is going to be 2 ohms times I sub 2. And if we continue, the last thing we encounter is the 3 ohm resistor. We know the voltage drop for the 3 ohm resistor is 3 I sub 2, because it's flowing in the same direction as we're summing the voltages, minus I sub 3, which is flowing the opposite direction. And that's equal to 0. So that's our second equation that we get from Kirchhoff's voltage law for loop 2. And now we have a third loop that we want to look at. And our third loop is down here in the lower right-hand corner of our circuit. And if we look at that, the voltage drop, again starting in the lower left-hand corner, we have a 2 ohm resistor that we can find the voltage drop for. And then we encounter the dependent source. And we don't know what the voltage drop is for this dependent current source. We could find the voltage drop for the 3 ohm resistor as we did in the last equation, and for the 1 ohm resistor as well. But we have a problem in that we have this voltage source, or this current source, in this loop. So we really can't write an equation that sums these voltages up unless we want to introduce another unknown variable, the voltage drop across this dependent source. So in order to avoid that, we use the concept of a supermesh, and we can define a supermesh around this circuit that allows us to sum up the equation, sum up the voltages around another loop. And so if we try to do that, we can try to do perhaps a loop around the outer portion and coming down the center part of our circuit, but we can't do that because we again encounter this 15 amp source and we don't know what the voltage drop is across it. So if we also look at another route, perhaps there's another route around this loop, and we don't see one, so what we need to do is we need to use our constraining equations that allow us to solve for this, to put this dependent source in terms of our loop or mesh currents. So we know that 1,9 V sub x, the current source, is equal to I3 minus I1. Okay, so that gives us another equation. So now we have how many unknowns? We have I sub 1, I sub 2, I sub 3, and V sub x. So we have 4 unknowns so far. So we need one more equation. Our last equation can be for V sub x, where we know V sub x is going to be equal to 3 times I sub 3, because I sub 3 is flowing into the positive polarity of our voltage drop V sub x across the 3 ohm resistor. So passive sign convention tells us, since it's the one flowing into the positive, that it is the positive current, minus I sub 2, which is flowing the opposite direction through the 3 ohm resistor. So now we have our 4 equations and our 4 unknowns. So if we solve for these, first of all, we already know what I1 is. It's 15 amps. If we solve for I2, we get an I2 equal to 11 amps. We get an I3 equal to 17 amps. And so we have each of our mesh or loop currents, I sub 1, I sub 2, and I sub 3.